Hello, everyone. Welcome to this LinkedIn Live session. You'll be able to view this either on YouTube or LinkedIn after the session. And if you have any questions that you want to ask, just pop them in the chat. I've collected a couple of questions from LinkedIn on HAZOP over the last few weeks. So I'm just going to answer those now. The first question I have was from Lahan. And he's asked, when we are marking up a node, should we include the valve or should we not include the valve when we end the node? So what I would say is this depends on what we have upstream. So for example, if we are starting at the boundary isolation, just give me a moment. Back. So with regards to where we mark up the node, if we're starting at the boundary isolation, the boundary valve will be part of our first node. When we're getting to the end of the node, we would include the valve depending on whether it is involved in the ESD or the control function of the upstream node. If it's involved in the ESD and control function of the downstream node, I would then put that valve in the downstream node and I would end at the inlet to the valve. If it's involved in the ESD of the valve that I'm marking up, I would include it in this node. Okay, so I hope that answers your question. The second question I have is from James, and it's some tips on vendor HAZOPs and how to integrate them into the existing PHA. Okay, so vendor HAZOPs. Vendor HAZOPs are tricky, especially when we're going through the project phase, because we quite often do not know who the vendor will be until after we have done our main HAZOP. So we don't have the vendor's HAZOP, we don't have the vendor's drawings. And so what do we do? Right? And we definitely don't have it in the feed HAZOP. So in the feed HAZOP, the approach that I take is I use it as a black box. And you say, okay, well, how could this black box impact our system? So if we take a glycol regen skid as an example, which is one I commonly come across. So the glycol regen skid, we would say, for example, we put more gas in than we've told the vendor that we will put in. So what is the maximum gas that we can put in? And then we would raise an action and say, look, ensure that the vendor knows that the worst case gas flow rate could be this, although that is an upset condition. And why would we want to tell them that? Well, we want to tell them that so that if we did have that upset condition, we wouldn't have a problem with the packing, we wouldn't have a problem with the trays, whatever we are having in the column. We also might have, for example, loss of cooling water from our system. How does that then impact the glycol system? Well, we know that that's going to lead to increased carryover of glycol. Is our system able to manage increased carryover of glycol? What will be the consequences? So, for example, we might have problems with our analyzer downstream if we're exporting the gas after the contactor. We also might have problems with the compressor if we have a compressor downstream. So do we have a upstream vessel which can catch that? And do we know what the worst case liquid droplet carryover is? So that's the type of process I would follow in the feed. We're just sort of doing a what if this happened, what if that happened, and either things within the vendor package or things external to the vendor package impacting the vendor package. Okay, so that's what I would do in the feed. But then when we get to the main HAZOP, sometimes the vendor comes with their own HAZOP. And what I would do then is typically I would import that into our worksheets, or I would just have them recorded next to me so I can see them. And then we would go through the normal guide words for the process. It depends on the consequences of the loss of the utilities. So, for example, the lube oil and seal oil or other utilities as to whether we'll HAZOP those. So always HAZOP the process pathway through the vendor package. And then through that, we can identify what the consequences are: loss of lube oil or loss of seal oil or loss of instrument air or whatever the situation is. And if the consequences are potentially high, then we should HAZOP the loss of the utility as well, or we should HAZOP the utility package. If the consequences are not high, then we don't need to HAZOP the utility package, and we can trust, as long as the vendor has a HAZOP themselves, we can trust that that is sufficient. Okay. Next question I have is HAZOP of flare systems. So flare, vent, and drain systems are often the parts of the system which are given to more junior engineers when we're HAZOPing, and also they are allocated the least amount of time. However, they are the most complex parts of the system. And so the approach that I take is that I will HAZOP the vent or drain line to the last isolatable valve of the system. So for example, I will HAZOP it to the relief valve or to the downstream valve of the relief if there's an isolation. And for closed drain system, I will HAZOP it to the last isolatable valve. This means that all of the things that can go wrong associated with the process, leaking relief valve, leaving a valve open from maintenance, that's all covered in the main HAZOP when we have the team who are experienced with those pieces of equipment. We should have hopefully the same facilitator throughout. So the facilitator is aware of the consequences from each of the systems. And then when we get to the flare, I would node it into different branches. And on each of those branches, I would ask, so is there a potential, because we're looking at more flow, for example, is there a potential that we could have one or more of these being activated at once? Can this exceed the design conditions of the branch? So in the flare HAZOP, we need someone who is familiar with the design of the flare system so that we can ask them those questions. But we do not need the specialists in each of the process things, because we now know what is the worst case flow rate, what are the different conditions when it could be flowing to the flare or the vent or the drain, because we know that from the previous work, and so therefore we don't need them in this HAZOP. Okay, and again, a lot of the questions we ask are probably going to have been covered in the flare study, simultaneous release, but this is our chance to really think about, are there any others that haven't been caught? Okay, so thanks, James, for those two questions. The next question I have is from Matthew. So I posted a tip last week about noding, and yes, Matthew has correctly picked up that I didn't say that we need different nodes for different modes of operation. So for example, if we are operating in a phase 1 approach and then we're going to be operating a phase 2 approach, we need to HAZOP each of those two phases. We cannot assume that HAZOPing one phase is going to cover the hazards of the previous phase. Okay. Also, if shutdown, startup are identified as high hazard activities for that particular node, then we would maybe want to HAZOP the procedure associated with startup or shutdown. Okay. And for example, pigging, so we would HAZOP that as a steady state process, and then we would definitely HAZOP that as a startup shutdown. Okay. Simon also raised a good point in the chat on that post. It was about batch HAZOP. And with batch HAZOP, I just wanted to mention that there is a difference between batch HAZOP and procedural HAZOP. But for both of those HAZOPs, we do need to understand the normal deviations, so temperature, pressure, flow, before we really understand the consequences associated with the batch. Okay. And with procedural, when we're HAZOPing the procedure, it's very similar to HAZOPing the batch. What if we did this step before we did that step? There is another process called safety critical task analysis, but that is normally done by a human factors specialist, and that is not done by a HAZOP facilitator or a HAZOP team, and it includes a site visit as well. And then Paul gave me a couple of extra questions, so I'll answer those, and then I can see we've got some questions in the chat. So I mentioned before that the timing per node is 4 hours. But in other industries, there is an expectation that each node takes 2 hours. I haven't found, unless the system is really well designed, I haven't found any nodes which we do in 2 hours. And that needs the system to be really well designed, everybody to really understand what the consequences and the design is, and for the team to really understand what HAZOP is. So that requires a lot of things to be working really, really smoothly for us to be able to get down to 2 hours per node. So I don't often see that. I have seen it, but I don't often see it. Typically, 4 hours is your best bet for scheduling. So what is the norm for the number of hours per day? So the industry norm is that we do 6 hours per day of HAZOP. And there's a couple of reasons why we do this. One is because HAZOP is pretty exhausting if you do it well, because we are constantly trying to break the system on paper. That's what our design is. We don't want to be doing that for 8 hours. Okay, because by those last 2 hours, we're not actually effective as a team, and we're really actually just wasting people's time. The second reason is that almost everybody in the team have got some other day job, and so therefore we need to let them go to be able to do that. Otherwise, those day job activities are going to encroach on the HAZOP. So, for example, they're going to start taking calls, they're going to start answering emails when they should be paying attention in HAZOP, and so therefore it would be better if we could do that beforehand, all right, or after the meeting, either before or after. So doing the 6 hours. Sometimes people say that if we have a team on rotation, we can, because they work 12-hour days, we can do the HAZOP for a bit longer. We can do it for a little bit longer, but I still haven't found that we can do 8 hours effectively with everybody paying attention and the team working really well, unless we're really in the flow of things. So again, it's just seeing how the team are feeling and checking in with them to make sure that they want to continue. Because again, although you're trying to keep time, quality is really important. And if we miss something critical, it's going to have an impact on the operator. And the last question was, when should we issue the terms of reference and issuing the PNIDs? So the terms of reference should be issued at least 7 days in advance, preferably 14 days. And the reason for that is because we want to give people time to come to us or come to the person organizing the HAZOP and saying, actually, that wasn't really what I thought we were doing in the HAZOP. I thought we were doing this, or why aren't we covering this part? Or do you really want the nodes like that? But the drawings need to be issued 48 hours before. This allows anybody to print out the drawings. It makes sure that they can download the drawings so that on the day that we have the right thing on the day, everybody has the right thing. Okay. So I'm going to answer some questions. I'm trying this. There we go. So thank you, Hisham. In HAZOP, do you recommend the equipment-based techniques or stream-based technique while working through the nodes? So what I recommend is that we node it according to a group of functions, right? And then we use the process-based guide words, the pressure, temperature, flow, etc. We use those. And then if we identify that there's a specific part of the process or a specific time during the process where there's a high hazard, we would then use different guide words for procedural. I hope that's answered your question, Hisham. If you can give me a bit more detail, if that hasn't, I'll come back to it. So I got a question from Tariq. Do we take vendor risk assessment on face value, or do we need to validate the adequacy of the eventual owner? So Tariq, this is a really great question. What you have to remember is that the vendor does not own the risk for your facility. If things go wrong, you as the owner are going to be prosecuted, and it is going to be your people that die. So if you take it on face value and it's wrong, the consequences are with you. So if you're happy to hand over your risk to other people, then yeah, take it on face value. But I haven't seen an owner who is willing to hand over that level of risk to somebody else. And even if we are not in an area where people risk is significant, even the business risk, a cost of a vendor package like a compressor can be quite significant and then can have a major impact on interruption to production. Do we really want to be leaving that to the vendor? And remember, the vendor are going to be designing to protect their equipment and to manage their system. They are not going to be designing to manage your whole process and your specific facility, where there may be other things which are different to where they normally install them. So I would always recommend that you revalidate it as a minimum or redo it. And that is at least the process part of it. And then, as I said before, just choosing whether you do any of the other elements depends on the hazards associated with that. I hope that's answered your question. Okay, so I've got a question from Mohammed. Some thoughts on double jeopardy in scenarios. So we try very hard not to consider double jeopardy. However, I will say that if we consider a sequence of events, that is not double jeopardy. So for example, if we consider Texas City, okay, so we've put too much liquid into the column, which has caused the column to overpressure, right? We now have the relief valve going off, and therefore the column is safe, right? The overpressure cannot happen. So we've had the overpressure of the column, the relief valve has gone off, we've not overpressured the column, everything's fine. Okay, actually everything is not fine because the routing of the relief valve is to an unsafe location. So that, although it may be considered double jeopardy, you say, okay, well, but the relief valve has to go off and there has to be ignition source associated with it. That's not double jeopardy. That's just working through the scenario and say, okay, well, now the relief valve lifts, it goes to this blowdown drum, which is not routed into a header, but is also located right in the process, and there are potential ignition sources around. So actually, we need to consider this now as another consequence. Double jeopardy often comes in when we start to put safeguards as initiators. When we try not to put safeguards as initiators. However, if a safeguard results in a dangerous consequence, the initiation of the safeguard results in a dangerous consequence, we do need to put that as initiator, because actually that is a design flaw. So an example of that might be if we have an ESD, which is like a trip and hold. So we shut two valves in, but we don't open a blowdown or a vent valve, and we have a liquid filled system. Okay. We then have thermal radiation that's going to result in an overpressure. So the action of our safeguard results in a hazardous consequence. We need to talk about that and whether that's the right thing to do. Okay. So we always try to avoid double jeopardy. And sometimes people will say that certain things are double jeopardy when they're not. And we just need to ask ourselves, are we continuing the story? Or are we saying that this needs to happen and this needs to happen? And remember, when we say that and, if it's and the safeguard needs to fail, that's not double jeopardy. That's just maturing the consequence. If it's just, it's this failure and this failure, that's when we're starting to get into double jeopardy. And what I would say is, on balance, we don't do enough of this because we know that process incidents are complex and they are typically not from a single cause. When we look at them, it's typically something causes it and several safeguards have failed. So just err on the side of caution, talk about it. And if you, at the end of talking about it, you realize they can't happen together, then that's fine, right? It's better to have spoken about it in HAZOP than for not to have spoken about it in the HAZOP and for it to happen in real life. So the next question I've got is, can I demonstrate the HAZOP being done? No, not in the LinkedIn Live, but I do have 2 courses which do demonstrate the HAZOP being done. I have one which is a pay on demand, which is available on the website, and I will be scheduling the live sessions soon, so you can access those on my website. I'll put a link in both YouTube and LinkedIn Live so that you can access those. Okay, because I do find that people can take away the theory of HAZOP, but without seeing how it's executed, then when they go to execute it, can make a lot of the easy mistakes in it and result then in a poor quality HAZOP. So I do have that demonstration available. Okay, so I've got another question here. This is our last question. What if the vendor came with an FMEA performed on the package, not a HAZOP? Do I exclude it from the HAZOP? So Hisham, again, it really depends on the quality. And what I would say is that the FMEA is probably going to help inform your consequences. And also it's going to help inform whether your safeguards are effective. Okay. So no, I wouldn't exclude it from the HAZOP. I would use it as information to feed into the HAZOP, but we would complete the HAZOP as normal going through the process pathway. Okay. All right. If there's no other questions have been asked, and I've answered all the questions that I came here to answer. I'll give it a couple more seconds, and if not, I will see you guys. I think next week I'll be having another session, and that session will be on inherently safer design. But if you do have any further HAZOP questions, you can always ask me those next week. Okay. Well, thank you all very much, and have a wonderful day. Have a good week.